Let's practice solving a quadratic trigonometric equation together. Now, remember that these types of equations can have an infinite number of solutions, but for this particular one, we're just going to focus on the solutions that are between 0 and 360 degrees, and when we have to do any rounding, we're just going to go to the nearest tenth just to be consistent. Let's start by just rewriting this equation together. So we have 5 multiplied by tangent squared of theta minus this 16 times tangent of theta, and that's going to be equal to negative 9 times tangent of theta minus 2. Now, if you look closely at this equation, you can notice that we do have a quadratic pattern here where we have one of these tangent functions squared, we have one that is not squared, and we also have some constant terms, so kind of takes a pattern of a quadratic function. That being said, we can just go ahead and simplify this equation a bit and use some u substitution. And let's just go ahead and say, let's let u represent this function of tangent of theta, right? So anytime we see tangent of theta, we'll write u instead, and then we'll make that substitution back later, but this will just help simplify it for the time being. Rewriting all of our tangent functions using this u, we're going to go ahead and write 5 times, instead of tangent of theta, we're going to write u. This is going to be u squared, since tangent squared of theta is just tangent of theta times tangent of theta. This is going to be minus 16 multiplied by u, and we can set this equal to negative 9 times u minus 2. Just like when you solve your other quadratic equations, we like it in standard form, so we're going to set everything equal to 0, move everything to the left side or right side of the equation, whatever your preference is. So I'm going to add 9u to both sides, but I'm also going to go ahead and add 2 to both sides as well. Alright, so doing that, we should end up with 5u squared, that stayed the same. Then negative 16u plus 9u is going to be negative 7u. And then after that, we just have this plus 2, and that's going to be equal to 0. Now, thankfully, this quadratic over here is able to be factored, so let's go ahead and set up 2 binomials here and set it equal to 0. And now, since 5 is a prime number, we know that our leading terms here are going to be just 5u and 1u, right? Just because 5 times 1 is going to be 5. And then in this first binomial, we're going to put a minus 2 here, and then in the second one, I'm going to put a minus 1. So if you want to pause to factor it, feel free to do so, or FOIL it out to make sure that works. Now let's see what makes each of these binomials equal to 0. So let's take this 5u minus 2 and set it equal to 0 and solve for u. So 5u minus 2 is equal to 0. We can go ahead and solve this by adding 2 to both sides. And so then 5u would be equal to positive 2. And then if we divide both sides by 5, we find that u is going to be equal to 2 to 5, or 2/5. Now, using that product property again, let's see what makes u minus 1 equal to 0. So u minus 1 is equal to 0. We can solve this by just adding 1 to both sides, and we find that u is going to be equal to 1. Going back to our equation, we can now say that we know u is equal to this ratio of 2 to 5, or this fraction 2/5, as well as equal to 1, or a 1-to-1 ratio. At this point, you want to remember what u really represented. We use some u substitution, so we can go ahead and back substitute and say every time we see this u, we're just going to write tangent of theta. So going back and resubstituting these tangent functions back in, we could say tangent of theta instead of u is going to be equal to that ratio of 2 to 5, and then this tangent of theta is going to be equal to the ratio of 1-to-1, or just 1. Now we have the ratios for each of these trig functions, so let's go ahead and use the arctangent function to figure out the angle. So theta here is going to be equal to arctangent of this ratio of 2 to 5, and we can use this to figure out that angle measure. And for this other trig function, we can say that theta would be equal to arctangent of positive 1. Alright, now if we go ahead and take this arctangent of 2/5 and plug that into a calculator, because that's not going to be a very nice value, we're going to find out that theta is going to be approximately equal to 21.8 degrees. Remember, we're going to round to nearest tenths place. And remember that since we are looking for angle measures between 0 degrees and 360 degrees, so we like this answer of 21.8 degrees, and we're going to use that as one of our solutions. Now, as for inverse tangent of positive 1, we don't actually have to use a calculator for that, but if you have access to one, feel free to do so. If you plug that into a calculator, you should find out that theta is going to just be equal to 45 degrees. Now that one is on the unit circle and is one that you want to be able to do by hand probably as well, but if we have a calculator, no worries. This one also fits between 0 and 360, so we like this solution. Alright, so while we have two solutions here, let's see if we can find more solutions, because I think we have a couple more. Alright, so to do that, we can take a look at the unit circle here. Alright, let's start with this ratio of 2 to 5, where we have this 21.8 degrees. So I'm going to say roughly that 21.8 degrees is right about here. Okay, so if I'm going to go ahead and draw a triangle, then this 21.8 degrees is going to be right over at this angle. Now remember, tangent has a ratio that is going to be y to x, or opposite over adjacent. So our y value here is going to be 2, and our adjacent value is going to be 5, or y to x. Now remember, this makes sense that we have a positive ratio because all our three trig functions are positive in quadrant 1. But keep in mind our other four quadrants, tangent is also going to be positive over in quadrant 3. Okay, so we can go ahead and get another positive ratio of 2 to 5 if we draw this same triangle, but over in quadrant 3 instead. So notice that's 180 degrees away. And so we can draw the same triangle here. This would be 21.8 degrees down in quadrant 3 below the negative x-axis. And while this is going to be -2 and -5, keep in mind that opposite over adjacent, a -2 over -5 is still going to be a positive 2/5 here. Okay, so while we have one angle over here, which is going to be 21.8 degrees, we're going to have another angle here that is 180, which is a semicircle, plus another 21.8 degrees. If we go ahead and take this 180 degrees and add on another 21.8 degrees to get over into quadrant 3, then we're going to end up with another angle measure that makes this true, and that's going to be about 201.8 degrees rounded to the nearest tenths place. This right here would be a third solution. Now let's see if there is another solution for when our tangent of theta was equal to 1. So we're looking for a ratio of 1. We have this 45-degree angle already. So again, this one is on the unit circle. So hopefully this one's a little bit more familiar. If not, that's okay. We can go ahead and draw this 45-degree angle that's over in quadrant 1. So that makes sense. This ratio is positive for tangent since all of them are positive over here. And tangent again is what? It's y over x, so you can think about that as 1 over 1, or its opposite over adjacent. So this is going to be 1 and 1, and so that's why that makes sense for 45 degrees to work. But where else is tangent positive? Well, we just did this a moment ago with the other ratio, and so tangent is also positive in quadrant 3. So let's go ahead and also draw a 45-degree reference angle over in quadrant 3. If we draw this triangle here, we can see we have another 45, 90 triangle. Now in this case, we have y is -1 and x is -1. But if we do -1 over -1, we still get the same ratio of +1. So while this angle over here was 45 degrees, that got us that ratio of 1 to 1. For our other angle, we have a whole semicircle, which is 180 plus another 45 degrees. So 180 plus 45, we can also say that theta would be equal to 225 degrees. I believe this would be our fourth and final solution that fits between 0 degrees and 360 degrees. Alright, so if we take all four of these solutions and put this together, we can summarize and say that theta here would be equal to, let's see, we have 21.8 degrees. We also have 201.8 degrees. Also, we have 45 degrees. And finally 225 degrees. And while there are other solutions, these are just the ones that are between 0 and 360 degrees. Alrighty, so that just about wraps up this video on solving this particular quadratic trig equation. If you found the video helpful, please consider giving it a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.